Okay, I'm not going to torture my students with a complete review of multiplying, but this is an example, for instance, this top one, of what we did in class before I started the recording, which is basically multiplying out a matrix, and we made sure it worked with this little thing. And then we got these 4 spots. We knew it was going to be a 2 by 2 matrix, so I drew these 4 circles because I knew there'd be a 2 by 2 matrix when I'm done. And there is our answer that we got by doing each spot. Like, for instance, this top spot right here is row 1, column 1, so we use row 1 and column 1. And we got -3 times x. And this spot right here, for instance, was row 2, column 1. So that's row 2 here, column 1 here, -xy. All right, we've already done the others, except this last one. I just asked them if they would tell me if it works. Is this a 3 by 3? Do I have that right? And then is it a 3 by 1? Do I have that right? Okay, then it works. And if it's a 3 by 3, or sorry, 3 and 3 in the middle here, then these two tell me my answer. It's a 3 by 1. You should know right away then that this is the same thing. It's going to be shaped just like that, a 3 by 1. So it's got 3 answers like this. Let's just do the top spot on that one. If you can do the top spot, then I'll know you could probably do all the rest of it. So how are you going to get this top spot right here? It's row 1, column 1. All right, I'm going to have you compare with the kids sitting next to you. I'm going to pair you right now, so I'm going to pause while I do that. All right, I got the kids clustered, and they are comparing with each other right now. For those of you at home, you should be doing the row 1 and column 1. And so x times x makes x squared. That's this one. And then the 3 times the 0 makes 0. The 2 times the 4 makes 8. What are we supposed to do with the 0 and the 8? We're supposed to add them all up. Final answer, x squared plus 8. All right. How many of you guys had x squared plus 8 as your answer? Okay, good. There was 3 parts. The x and the x made x squared. This made 0, because 3 times 0 is 0. 4 times 2 makes 8. And you add them all up. X squared plus 0 plus 8 makes x squared plus 8. All right. I think you're getting the idea. Now let's move on to the inverse. You need a calculator for this one. If you still remember the process, you probably still couldn't do it with a 3 by 3. That process, the 1 over the determinant thing, starts to break down right away when you get to get the determinant of something like that. We are not expecting you to go that far in this unit. So it's fine with us if you have a calculator and you use the calculator for this. Okay, so if you need to borrow one, leave me some collateral and borrow one quickly. And then hopefully you know how to enter this. I would call it matrix A, but if you want to use any other letter, go ahead. But I'm going to be using A. And then the inverse, remember, is the little -1. You put it to the power of -1. I'll pause while I put that in my calc. Okay, so here's how I'm putting it in. I've got my matrix menu up, which I found underneath that red key right there, above the -1 button. And now I'm going to edit matrix A, so I arrow over to edit. You got to be in the edit area. Okay, and then I got to know what I'm doing. It was pretty much a 3 by 3. 3 by 3. There we go. And now, there it is. I'll move the calculator over here. So I have -2 is my first number. And I just type them in. It goes to the right automatically as I hit enter. Alright. Now, who can remember what to type next? Do you remember how to get the actual inverse in there? How do I get the A up there, the matrix A? Second matrix, and then I hit A right away. Good. To the negative first, you are correct. And there it is. Now those are just my first 3 numbers in the column. Okay, you get how that's kind of a pain to read? Could I make it round them? Yeah, but it's beyond the scope of what we're going to do. You'd have to go back into, I wouldn't do this, just so you know. If you ever want to round stuff, you can round stuff in your menu here. Okay, so I'm going to do it, and then I'm going to undo it right away. If I want to go to, let's say, 1 decimal place, I'm going to go float 1. And then I'm going to go back, quit out of this, and then I'm going to do the same problem over again. Matrix A to the -1, and boom, look at that. It rounded them all to 1 decimal place. But you know what the problem with that is? Kids forget they did that, and their calculator from now on till the end of time is going to round to the 1st decimal place. You see how that could be a problem? Because you're going like, okay, what's 1/3? 1 divided by 3. We know it's 0.3 repeating, right? It says 0.3. And it's totally a way to mess with somebody's head, because now the calculator is going to round and they don't know why. And they're like, they probably wouldn't even notice. So anyway, I just want to be, that's why I said don't do it, because you'll maybe forget it on there. If you did do it, get it back to 0. No, wait. Just get it back to float, sorry. We want a floating, not rounded to a spot. All right, so now I'm in normal mode again, and now if I get out, but it was kind of cool to be able to see all the decimals in that matrix. So if you wanted to do that, and we had said round to 2 decimal places, you could do it. Just make sure you don't leave your calculator that way. Okay? All right, so what is this thing again? It's an inverse. That means if I multiply this matrix, which I just rounded and therefore it's not going to work perfect anymore, but if I were to take this times the inverse matrix, you'd get 1. But wait, there's a problem. What did I just do kind of really quick that would actually make it not work? Besides the rounding thing, that also would make it off a little bit. Do you remember that the order matters? Your inverse needs to be on the left side when you multiply by the other one to make it equal the identity matrix. Or remember what the identity matrix looks like? 1, 1, 1 with all zeros and all the other spots. Okay, so to get 1, or the matrix equivalent of 1, which looks like this, you have to multiply something times its inverse. But you can't put the inverse on the right. Your inverse needs to be on the left. Why on earth is it so picky? Because when you multiply matrices from left to right, it's different than from right to left. In other words, A times B is different than B times A. Okay, so that's another big important thing on the review day we got to remind you of. Okay, let's say I was doing this one. The point is to solve for C. It's not a bad idea to just like underline C, just to remind yourself that's what I want to get alone. So it follows the order of operations, as in adding and subtracting stuff should be done first. So we should get rid of this, because this is a positive matrix. See, there's no negative in front of it, right? It's a positive matrix, so I'm going to subtract that matrix from both sides. Minus 5, 5, negative 3, 8. Okay. And when I subtract this matrix, I'll trust that I could have squeezed it in here, and it's a lot of writing. I can just make it disappear, because when I subtract that matrix, it will make it disappear if you're subtracting the exact same thing. So now you just have to subtract these two. Well, that shouldn't be that hard. And then what? There's R. How are we going to finish this thing? The only problem with what you said is that there's no such thing as dividing in matrix land. There you go. And that is also known as the inverse of negative 3, right? So negative 1/3 is what you'd multiply both sides by. So everybody do that. Finish this deal. Get that. And then when you have that answer, multiply both sides by the inverse. I'll pause for a second while you give that a shot. Okay, so I wanted to show you how to do this one. This one minus this one makes negative 9 in my parenthesis, or in my matrices, sorry. 1 minus 5 makes negative 4. 0 minus negative 3, that really means plus 3, it's 3. 7 minus 8 is negative 1. Then I have to remind myself that I have a negative 3 still to get rid of. So I multiply both sides by the inverse of negative 3, which is negative 1/3. Negative 1/3. That becomes a scale multiplication problem here. Here it just disappears. Yay, they're gone. C's alone. Now I got to do that scalar multiplication of every number. So C equals positive 3, positive 4/3, positive 1, nope, negative 1, and positive 1/3. There's your answer on that one. Raise your hand if you had that one right. Okay, good. That's a good sign. If you didn't and you see what your one little dumb mistake was, that's fine. All right. Solve the system using matrices by setting up an equation. All right. So for this, I'm going to recommend that you know 2 ways to do it. One way is to make a matrix for this part and then have an XY. So we have a matrix here and then a really small XY matrix and then a matrix for the answers. Everybody make me one like that. And notice it has to be in order. Your X's first, then your Y's, then your number. I guarantee you, when you take a test on this, we're not going to always make it nice. We might have a nice one in there, but we're also going to have it rearranged. You've got to get them in order with X's first, then Y's, then numbers. So did you have 4, 1, 1, negative 1, and 2, and 3? Raise your hand if you're good on that. Okay, good. Then, to do it this way, we would need to take the inverse of, if this is the A matrix and this is the B matrix, we need inverse of A to be right here. That will get rid of this. See, and then the XY will be alone. So if I do inverse of A on that side, I got to do inverse of A on this side. One of the most common mistakes is people forget and they put the inverse on this side. Do you get that you can't change around the order and get the same answer? Okay, so you've got to do it in the right order. It's got to be inverse of A times B. Well, if this is A and this is B, you should be able to use your calculator and figure out what inverse of A times B is. Go through and put in a matrix A and matrix B and then finish this puppy off. And then I'll show you that one last thing, how to do it as an augmented matrix, which I think is easier. And I think we're going to allow for both on the test. Let me pause for a second while you do that. Okay, so I double checked, and yes, you are expected to you have to know how to do it this way, because they're going to specifically say, write the answer to this in the form, you know, where you have 2 matrices, A and B, etc. So you can't just lean on the other way, even though I know the other way is faster and easier. All right, so this way, you'd have to go inverse matrix on the front here, A, negative 1, and you're totally welcome to use a calculator on that. So I'll show you. I'll pause for a second while I get this calculator ready. Okay, I've entered both my matrices. One of them is matrix A and one's matrix B. And now, just like it says right here, and this is what you can always do, inverse of A times B. So you go, here's inverse of A, matrix inverse of A. Here's inverse of A. Now, do you get that if I had messed up typing in my matrix, I would never know it right now? I'm not going to even see what matrix A is. And then I'm doing the inverse of it. And then I'm timesing that by B, matrix B. Again, I'd never know it if I typed one of those numbers wrong. Okay, so if I were you, you can't just tell by looking at the answer either. If I were you, I would not just assume, oh, I'm sure I've got this right. Although, frankly, if it comes out to weird decimals, it might be a clue that there might be something wrong. But 1, negative 2, how many of you got that right? Okay, good. If you didn't, I would go back to your matrices. I go into matrix, I'd look at A, and I go to edit, and I just look at it, double check your matrices before you feel confident you got the right answer. Because all it takes is one number wrong in a matrix, and your whole problem's wrong. Okay, you type in one number wrong, and I do it all the time. These are a little bit clunky to enter. So I'm going to go look at my other matrix in matrix B, editing B, making sure that I did that right. 2 comma 3 or 2 over 3. Yes, it's right. So then I can trust that that other calculation answer of 1, negative 2 is good. All right, I want to show you one more thing. Everybody go to back into matrix A. And we're going to edit something. We're going to change it so it doesn't work out quite so nice. We're going to change this to, it's still a 2 by 2 matrix, but we're going to make it 4.8 as our first number instead of 4. Of course, that's going to mess up some things. Okay, now we're going to go back out and we're going to do matrix, we're going to do the same exact problem we did before. You just hit enter, it'll redo the same exact problem. Do you get now that I have nasty decimals? Okay, do you know how to change those to fractions? Because we are expecting you in the directions on the test, we're expecting you to know how to write your answers as fractions. Now, are they going to be this nasty? No, I'm sure we wouldn't do anything this nasty, but if your fraction answer was 1/2, we'd rather have you write 1/2 than 0.5. If it says 3.5, what's the fraction for 3.5? Something divided by something. 7 over 2, very good. Okay, now if those don't come naturally to you, you better know how to do this. Math, you see that very first one? It says like arrow frac. That means change your answer to fractions. Enter. Now, have I actually done anything yet? No. Enter. Math, enter, enter. And now look at that. It changed your answers into fractions. Math, enter, enter. That'll work with anything. Even if I just had I want to know what 0.125 is as a fraction. I go 0.125 and then I go math, enter, enter. Changes to 1/8. So in case you didn't know that one, that could be handy. Math, enter, enter. Okay. So, I think that's all you would possibly need to know. Other than in a word problem, you have to be able to write an equation. So let's just do one more reminder how that works. Let's say I have 3 times as many, let's go with something X, xylophones, 3 times as many xylophones as yaks. That way I can use X and Y. 3 times as many xylophones as yaks. Three times as many xylophones as yaks is totally wrong. It's so easy to think it's that way. Remember how it goes the other way? If you have 3 times as many xylophones, then do you get Z is way bigger than Y? Oh, dang, sorry. Sorry, yeah, I meant it to be an X because I wanted it to be X and Y. But either way, 3 times as many xylophones as yaks. If this is 3 times as big, then do you get we got to take the Y and times it by 3? Remember that? It's kind of counterintuitive. It goes the opposite way you'd think. How many of you had it right? 3 equals, or sorry, X equals 3 times Y. Okay, good. All right, then you won't be hopefully fooled by that kind of thing. So you have to be able to write an equation like that. Does that look like an equation that well, first of all, is that set in the normal way where you have X and then Y and then the answer? No. So X minus 3Y equals 0. Now it's set in the normal way where you have X and then Y and then 0. Okay, so this was a right answer, but it wasn't set up right to put in a matrix. Let me give you one more like that. If you take 5 times the number of yaks and subtract 2, you will get the number of xylophones. 5 times the number of x minus 2, you get the number of xylophones. I know I spelled xylophones wrong there, but that's okay. Did you get I was going for 5y minus 2 is equal to x? Now, do you get that that is not in the right order now? So everybody rewrite these in the right order, then write a matrix problem for it. I want to make you solve it. Just try to write the problem out right. Rewrite them in the right order, so you got x first, then y, and then the answer. And then make a matrix problem that looks like this. Numbers, then your x, y, then more numbers. Okay, so this equation here is the one that was not written in the right order. I'm going to bring this x over to this side. So it's going to be negative x. That's a positive 5y still. And then the negative 2 here, he needs to go to the other side over there. Equals 2. See, x is first, and then y, and then the number. So then, if you look at this as a big matrix, it's 1, negative 3, negative 1, 5, then the x and y, then a 0, 2. Raise your hand if you had that one right. Okay, I think you guys are doing okay on this. So now, let's spend the rest of the time working on the review. I've got that right here. Pause for a second. Okay, so we've got the homework open here. Evaluate each operation and simplify answers as much as possible. So this first one's just a multiply, the next one's an add, then we got another multiply. Notice how there's lots of variables in there. That's because we're letting you use your calculator, and we don't want you just to put them all into matrix A and matrix B. You can't. If we put variables like that, it won't do it. So you have to know how to do it by hand. Okay? So you can't just use your calculator as a crutch. There's very few, actually, where you can use your calculator. You get up to, here's the first place where you'd be able to use a calculator. And on the test, it'll be similar in that respect. You can't just expect, oh, I've got the calculator, I'll be fine. Because there's variables thrown in. All right, so use the matrices and a system of equations below to solve for x and y. This is the kind we just practiced. And remember, look at this one, it's not arranged right. You got to be able to arrange them so it's first x, and then y, and then in this case z, and then just a number answer. So this last equation here is messed up in that it doesn't have some of the variables, so you put 0 of them, and you've got to have it rearranged. And then there's a couple word questions. These will be the hardest ones, of course. I think it's reasonable to cut this down a smidge. If by now you don't know how to subtract, you're probably doomed anyway, so let's skip number 4. Granted, you could still learn it, but I'm just saying it's an easier one, so let's not worry about that one. So skip 4, and let's... These two are pretty much identical, so it's okay with me if you skip number 7. So why don't you skip 4 and 7? The rest of them, do them, and of course, if you need to practice, do number 7. No reason not to. And check your answers, and then make sure that you are really ready for this test tomorrow. All right, that's all I have for you for today.